Hello, everyone. Good morning, good afternoon. Just wait a few more minutes until everyone else will join up, and then we'll start the webinar. Thank you. Okay, so I guess everyone's joined in. So please let me introduce myself. My name is Joseph Kachala, and I work in GFI as a sales engineer for regions EMEA and APEC. And today we are going to talk about the newest product in our portfolio, which is called the Exinda SD-WAN. So first, as usual, the agenda. So we'll talk about the SD-WAN as a solution in general. Then we will jump into our solution, so the Exinda SD-WAN, and we will finalize the webinar with a short demo where I'm going to show you live what we can do and how the solution can help you. So SD-WAN, as you know, bandwidth requirements are increasing, especially for applications. It can be expensive and difficult to expand WAN capability with corresponding difficulties related to network management and troubleshooting. Today, organizations need agile, flexible, and cost-effective IT solutions if they want to compete effectively. They need the solutions that are easy to implement, that are scalable, and that meet the needs of growing businesses. Also, in the world where downtime can affect both the reputation and the revenue, companies need to be confident that chosen networking solutions are always operational and fault-proof. So this is what the SD-WAN is all about. Of course, SD-WAN is not a new term, definitely not to Gartner. Gartner basically said that SD-WAN is killing MPLS, as it is much more cheaper and affordable by a wider audience. By 2020, more than 50% of WAN edge infrastructure will be refreshed with use of SD-WAN devices. There are key factors which are driving this change, and they are, for example, public cloud computing, which is making traditional WAN architecture insufficient. Then enterprise WANs are drowning in complexity and high cost. Digital business transformation has increased the urgency of stable and efficient solutions. And at the end, aim of all companies, no matter what's the size of the company, is to improve the performance of all applications, including those who are sitting in the cloud. So now let's have a look what are the main benefits of our Exinda SD-WAN. So according to what I just said, one of the key factors or key benefits is, of course, higher performance or efficiency of your WAN connections. Everything has a cost, and every company and every department has a budget to stick to. SD-WAN is a very affordable solution. You can use commercially available internet connections, which could be directly plugged into the SD-WAN box. You can manage up to 12 internet transports. You'll have additional speed exactly when it's needed. And finally, it works perfectly with our Exinda network orchestrator. Currently, Exinda SD-WAN could sit on 3 different hardware boxes. We have Exinda SD-WAN 300, Exinda SD-WAN 1000, and Exinda SD-WAN 10 gig. The main difference between the boxes is, of course, in the hardware capabilities, because each of the boxes has a different amount of RAM, different CPU, different amount of ports, and so on and so on. So these specifications are, of course, having a direct impact on the supported throughput, on the number of concurrent IP sessions, and other values which could be configured within the web user interface. Full specs of these boxes could be, of course, found on our website. So I encourage you to take a look and see which of the device is meeting your requirements. So where does the Exinda SD-WAN sit in the network? So on the screen, you can see a very basic topology, but also on the other hand, it's a very common topology where the Exinda SD-WAN is sitting exactly at the edge of your network. That means that all the internet connections are plugged in directly into the Exinda SD-WAN. And behind of the Exinda SD-WAN, you can have all the other devices like Exinda network orchestrator or switches or firewalls or whatsoever. But as I said, this is one of the possible topologies. There are many other topologies which are basically fitting different requirements in different environments. In the following slides, we'll talk about the main features of Exinda SD-WAN, which are, for example, link aggregation, VLL and application tunnels, load balancing, built-in firewall features, QoS, and finally, manual network routes. So first of all, link bonding, which is, from my opinion, one of the most important feature which is included in the Exinda SD-WAN. So in computer networking, the term link aggregation applies to various methods of combining multiple network connections in parallel in order to increase throughput beyond what a single connection could sustain, and to provide redundancy in case one of the links should fail. So let's have a look on the slide so we can see the example. So in this scenario, we have 4 internet connections. Yeah, so we have DSL, 4G, LTA, and SAT-Link. If we are going to perform an HTTP download, basically this download will go only from a single pipe. So in this case, I choose the DSL, but it could be 4G or LTA, it doesn't really matter. So we are going to utilize only 10 megs. So the download will be only that fast. This is the standard situation without having an SD-WAN solution in the network. Once we are going to bring the SD-WAN solution in the network, and in this case, it's sufficient to have the Exinda SD-WAN in the single instant mode, which is one of the 2 possible modes. I will explain the second one on the other slides. So we can exactly perform the link aggregation, as I mentioned. So we are basically going to combine all the speeds of all possible connections together. So we'll not be downloading at 10 megs, but we'll be downloading 23. So we'll be going higher with the speed. And if something will happen, let's say the LTE will fail, the only result would be that we'll have less speed, but the download will still go on because it will not be interrupted at all. So this is the link bonding from the HTTP or HTTPS download perspective, which is available in single instance mode. Now let's talk about the paired mode. And with the paired mode, as the name says, you need to have at least 2 devices. In paired mode, you can use the VLL or the virtual leased LAN. Basically, virtual leased LAN is a way to provide an Ethernet-based point-to-point communication over the networks. The Exinda SD-WAN, as I mentioned, can be configured in a paired mode if one of the Exinda SD-WAN has a server license. The tunnel can basically, which is going to be established between the 2 boxes or multiple boxes if you like, the tunnel can use a combined capacity of multiple resources. By resources, I of course mean the internet connections. So the capacity of this tunnel can be close to the sum of the capacity of the individual resources. From the stability perspective, we are also going to improve significantly as the tunnel will remain operational as long as there is at least 1 active communication path. A second scenario also requiring the Exinda SD-WAN to be running in the paired mode is with a connection with the cloud-based SD-WAN relay. So in this case, we are not going to be connecting to a second box, but to a cloud-based relay, and we can utilize all connections to get this done, to connect to the relay. Virtual leased LAN, okay, so how we can truly benefit from this in practice? A lot of, if not all companies are using VPN to connect their branch offices with headquarters. This VPN is often very important as users located in branch offices are using applications, servers and services, and who knows what else, which is actually located in the branch office, in the headquarters. Basically, when there is a limited or no connection between the two sites, business is suffering and employees at the branch office are far away from being productive. VLL, or the virtual leased LAN, is an excellent feature to assure functionality and quality of such connection. It's not unusual that companies currently have multiple ISPs, but VPN redundancy is in many cases not automatic, and some reconfiguration is always required. Reconfiguration naturally takes time, and more time is having more impact on the workflow and on the revenue. And of course, in some cases, there is not an administrator to do it, so some professional services might be involved. That means that additional costs are involved as well. So in the practice, as you can see, in the headquarters, we have 4 connections, 4 ISPs. In the branch office, we have 3 ISPs. We want to do the VPN tunnel, and we want to utilize the VLL to do so. So with the VLL, as I mentioned before, we can combine all the links together. So we can basically make the VPN pipe much more bigger, so we'll have bigger throughput. And along with it, we also can supply with a failover, so the VPN tunnel will be alive as long as there is at least one internet connection still operational between the two Exinda SD-WAN devices, so between the headquarters and the branch office. Now, from a different perspective, VPN is widely used, no doubt, but I would say the VoIP is equally used as well. So let's imagine a situation that we have a company A and company B doing currently a very important conference call. Company A has heavily invested into multiple internet connections. So we have ISP1 and ISP2. Currently, the conference call is ongoing and the packets are going from the ISP1 connection. So if something will happen with ISP1, well, they will lose the conference call, because what they need to do now is to reconnect, possibly reconfigure. So basically they will experience downtime, and maybe it will have a very, very bad impact on the whole deal, and so on and so on. So what we can do to help, in Exinda SD-WAN, we also have a specialized tunnel for VoIP, which allows for the establishment of a specialized bonding tunnel that is optimized for voice traffic with respect to the latency. So basically what we are doing is that several algorithms work simultaneously to ensure that voice traffic is traversing the best possible path in terms of jitter, loss of packets, latency, performance history, and others. So basically we are measuring on the continual basis all the passable paths. So right now, in this scenario, 4G is the best passable path, because the result, which is Exinda SD-WAN doing on a regular basis, is the best. But if this will change, then it means that the 4G, as you can see, will no longer be the best passable path. And in this case, it will be exactly on the level of the settling. The DSL will be considered as the best passable path. That means that all the packets will be automatically redirected through the DSL, and there will be no interruption to the voice call. So basically, from the user perspective, even when the path, the ISPs will change, the user will not experience any downtime or any kind of issue. There might be a possible glitch, but it will be only a few milliseconds. So back to our scenario. So again, the company A and company B are having very important conference call. Company A has 2 ISPs, and something will happen to the ISP1. But in this case, we already have the Exinda SD-WAN using the VoIP tunnel in the paired mode. So if something will happen with ISP1, basically nothing will happen to the conference call. Still ongoing, no issue. So with Exinda SD-WAN, we can find several types of tunnels which are being used for specific type of traffic. We can find the application tunnel, VoIP tunnel, and finally video optimization tunnel. So let's have a look how we can use the the application tunnel with respect to load balance. Application tunnel is using advanced load balancing algorithms whereby packets from the same source IP or destination IP or protocol or ports are load balanced onto a path in such a way that packets from the same flow are forced to use the same path. Real-time measurements are also applied as before, so we are measuring history, performance, throughput, packet loss, latency, transport disconnect, and so on and so on. And as before with the VoIP tunnel, this is being done on the regular basis. This is the true benefit, that we are measuring all the time, all the paths non-stop. System creates a path whitelist and a path blacklist. This basically means that the packets are always going through the whitelisted path. And if the status of the path will change, that means that, let's say, the path will become a blacklisted path, then the packets are automatically redirected through the new whitelisted path or through the next whitelisted path. That means that there is always a connection which is able to be used for the communication. So by default, the Exinda SD-WAN device will equally load balance all the HTTP and HTTPS traffic. As we mentioned in the beginning, with the aggregation of the links during the HTTP or HTTPS download, this could be done in standalone mode. So you need only one single device, and you don't even need to have the cloud relay, which I already mentioned before. This feature can also work. Basically, you can influence this feature with the HTTP aggregation weight if you want to have more control on how the balancing is being done. Next feature is the built-in firewall. Using the firewall feature, you are able to create inbound and outbound traffic rules where you can choose what will happen with the traffic. If it will be rejected, dropped, or accepted. The traffic could be filtered based on the source IP, destination IP, source ports or destination ports, and many, many other factors. So pretty much basic firewall rules. Multiple firewall rules can be added to achieve desired outcome by means of priority. So now the QoS. Exinda SD-WAN combines traffic shaping for inbound and outbound traffic with the dynamic bandwidth reservations. Bandwidth reservations carries out guaranteed bandwidth for different types of traffic flow when they are detected in the network. If not present, the reserved bandwidth, of course, will be released for consumption of the other traffic flows. So pretty much, if you are familiar with Exinda Network Orchestrator, this is very similar, but of course, in the Exinda Network Orchestrator, you can do so much more. This QoS, or the aim of this QoS, is to work closely with the VLL tunnel. Manual routes. So manual routes are used in scenarios where you have multiple subnets on the LAN segment, or you want to specify certain subnet traffic to use a specific remote LAN or a WAN link. There are three different types of routes: simple route, advanced route, and connection route. In each of these routes, you can use device type, which identifies the interface, or a tunnel type of for the traffic we are setting the route for. Basically, the main difference between the simple route and advanced route is just in the number of options you can use to specify the route. Connection route is, on the other hand, a little bit more specific, as it will track flows as connections, and routing will be done based on those connections. Now we can jump on the collaboration between the Exinda SD-WAN and the Exinda Network Orchestrator. So basically, with those two devices in the same network, you can benefit from load balancing, link aggregation, traffic visibility, tunneling, routing, compression, WAN memory, edge cache, advanced reporting, protocol-based acceleration, and so many, many more. These are just an examples I choose to add into this slide, but there are really, really more and more benefits with those two devices in the same network. So if we have a look on that, so we have a Exinda SD-WAN in the front, and we have, again, 4 connections. In the back, we have the Exinda Network Orchestrator, which is, well, connected to the LAN. And let's assume that we are going to, we are having a trouble with updates. We don't really know what kind of updates there are, but we know that when the update is happening, we are experiencing issues in the network. So what we can do in such scenario? So of course, we will use the Exinda network orchestrator from the visibility perspective. So we will discover what devices or what possible updates there could be. So we will discover there are some Apple updates, Android updates, Windows, and Linux updates. So this comes from the Exinda traffic visibility. So the next thing we would like to do is to shape that traffic. That means that we can create a policy where we'll allow these updates to perform only at specific time. So it will be, I don't know, some during the weekends or after the working hours. So we'll not be using the internet connections when we need it for the business critical application. Now, on the Exinda SD-WAN side, in the single stand mode, we'll perform the link aggregation and load balancing. That means that when the time comes, that means that we want to download all the patches, all the updates for the Windows, Linux, Apple, and Android, we will utilize all links together. That means that the updates will be very, very fast. On the Exinda end, we'll benefit from the edge cache because once the updates will be downloaded, then all the updates will be also cached on the Exinda. So if there will be any need to download the same update again, we will not be using the internet connection. So they can be used for something else, something more important. So this is one of the possible scenarios where you're using the features of both the Exinda devices, so Exinda SD-WAN and Exinda Network Orchestrator. Another scenario where previously we talked about the VPN, so it's a good idea to bring up the VPN once more. So again, we have the Exinda SD-WAN, we have the Exinda Network Orchestrator, 4 connections, we have the LAN, we have the VPN terminator. So what we'll do is that we'll use the visibility function in the Exinda to recognize what kind of traffic is actually going through the VPN tunnel. Then we can use the VLL, so we'll be combining the links, so we'll perform the link aggregation, we can do the routing, plus we'll also benefit from the failover. So that means that the VPN tunnel will be still on as long as there is at least one internet connection alive. On the Exinda side, we can then also do the traffic shaping. So we'll, I don't know, we can, for example, not allow certain applications to go through the VPN tunnel. Then we can apply compression, WAN memory, and protocol-based acceleration. So again, we can combine multiple features from both devices to achieve the best possible solution for VPN tunneling and so on. The same could be applied on the Office 365. So as many of you know that there is a problem when you have Office 365 sitting in the cloud and you have an issue with the internet connection, or you have additional applications consuming your internet connections, then you don't have enough bandwidth for all the Office, for all the Outlook and PowerPoint and other services coming from the Office 365. So again, the same combinations of the features coming from the Exinda SD-WAN and Exinda Network Orchestrator. So now we'll jump into a demo where we will also be cooperating with my colleague, Eric. So the demo will consist of basically everything is virtualized, but basically the connection looks like this. So we have a Linux server, which is virtualized in our branch office sitting in Holland, sorry, Netherlands. Then we have the Exinda Network Orchestrator and Exinda SD-WAN. The Exinda SD-WAN has 2 ISPs, which are connected to WAN 1 and WAN 2. The LAN is connected to the WAN port of the Exinda Network Orchestrator, and the LAN port of Exinda Network Orchestrator is connected directly to the Linux Ubuntu host. So basically, we have a single bridge in the Exinda Network Orchestrator. So let's have a look how this performs. So I hope everyone can see my screen. Let's be sure. Yeah, you should see it, hopefully. So this is the Exinda network orchestrator. I was just logged out, so I need to fast log in. Okay. So as I was saying, we have only one bridge and one LAN and LAN-WAN connection on the Exinda network orchestrator. So as you can see over here, only one bridge. So this is the client. So this is the Ubuntu, and this is the interface of the Exinda SD-WAN. So as you can see, we have two WAN connections, yeah, and one LAN connection. So this LAN connection, as I mentioned, is connected directly to the Exinda network orchestrator. So as you can see, both links are being utilized at the same time. So what will happen if I'll perform an HTTP download? So I'll go to the Ubuntu client, and I'm using this Think Broadband link, which is widely used, and I'm going to download a 1 gig file. So click on OK. So let's have a look what's happening. So if we go back to the Exinda SD-WAN, we should see that both links started to download the file. So we can see the speed on the LAN is basically 55 kilobytes per second. So we can see that it's basically a combined speed of those two WAN connections. So really, I'm aggregating the two links. If we have a look on the Exinda network orchestrator, and we'll go to the real time to see the real-time traffic, and in the conversations, we can see the same website. We can see HTTP is being used, and we can see 53 megs per second. So if we go back to the Exinda SD-WAN, we can see pretty much the same value. It's going up and down. So and the refresh rate of the conversation tab is 30 seconds. So we are seeing currently different value, but if it will refresh, it will see again a different value. We can change that into 10 seconds, or so it will be more faster on the refresh. So the result is that the Ubuntu client is going to download the file at speed higher than 50 megs, which are two links combined. So now let's have another test. So, okay, I need to reload. So I was watching a Sky News live broadcast over here. So in this case, we are going to basically utilize the VLL, so the virtual leased line. So we have the tunnel done through this Exinda SD-WAN to the cloud relay. That means that the cloud relay is the single connection where we are going to connect through multiple ISPs which are plugged into the Exinda SD-WAN. So what will happen if I'm going to kill one of these connections? As you can see, the broadcast is still ongoing. So I will use PuTTY to connect. So, okay. So now I'm going to basically simulate an issue with one of the ISPs. Most likely I will choose ISP 2, so the second WAN connection. Okay, so now we should see an issue in a few moments. So it will tell us like trying to connect or something. So let's wait a bit. Yeah, so we see that it dropped, and in a moment we should see a problem with WAN 2. It takes a little time until it will be diagnostic, but still over here we can see the broadcast is going on without any interruption. Yeah, 0, 0. So we have only one link being utilized, but still the status didn't change, but it will change in a bit. Let's try to, yeah. So we see the connectivity has been lost. Yeah, but still we are operational with the streaming. So basically, now we are using only one link. So if I'm going to bring it back online, we'll see that we'll be using again both connections for the YouTube streaming. So again, this will take some time until it will reconnect, but not too much, only a few seconds. Yeah, here we go. So back connected, and in a moment it will, yeah, so we can see now. So now let's have another test. So we were talking about conference calls and VoIP over IP. So for that, I asked my colleague Eric to help out. So hello, Eric. So we can see you over here. So he's now currently in our office in Vienna. And basically what we are doing is that we are using a Zoom application for the conference call, and we are connecting through the Ubuntu, so through our demo setup, which is located in Netherlands, directly to the Zoom server. Eric is doing the same, and we are basically having a conference call. So what will happen if we are going to kill one of the connections? So this time I will choose the first connection. So again, PuTTY. So change it to BRVM4. Yeah, so now it's killed. So what will be now is that basically I cutted myself from the web user interface of the Exinda SD-WAN, but that's fine because we can still, the traffic should still go on. The conference call should not be interrupted because we still have the second connection. So now if I'll click on the advanced, I will not be able to go around the web user interface because I'm using the first IP address to connect to the Exinda SD-WAN. Yeah, so here we go. But we can see that Eric is still there. That means that our conf call is still ongoing. So to prove that I'm not lying, let's bring up again the interface online and let's kill the second interface. So yeah, let's reload the, yeah, so we are back online. So the first interface is working. Yeah, here we go, working. And as we can see, the second interface was more utilized because the first one was not working at all. So now let's kill the second one. So again, we'll go to BRVM6, shut down, so kill. So again, we'll see that this will drop and this will go up. And let's see if we can see Eric. Yeah, Eric, hello. Yeah, we can still see Eric. So absolutely no issue, and the conference call is ongoing without a problem. So this is the benefit of the virtual list LAN, and this is one of the main benefits of Exinda SD-WAN. So you have multiple ISPs, you have multiple internet connections, you are using them at the same time, you are able to provide seamless failover without zero reconfiguration, and you are able to aggregate multiple links together. So as I promised before, let's have a look on the other parts of the Exinda SD-WAN. So in the advanced tab, you're able to do the HTTP aggregation weights, as I mentioned. You're able to create manual network routes. So it's very easy, very simple. So click here, you can choose simple, advanced, and connection. Then you add desired options. Then in the firewall section, you can add firewall rules, as I mentioned during the explanation. So you can choose if it's inbound, outbound. You can choose the interface. You can choose the protocol. Then I also mentioned the QoS. The QoS is also being configured in advanced tab. So you have over here, for example, quality of service reservations, So you can choose, yeah, if you want to do it per host or layer 7 filter, you can choose the device type, if it's ingress on ingress, priority, protocol, and so on and so on. So multiple options. If I'll go to the Exinda network orchestrator now, then we can see still the traffic which is happening on the Ubuntu. So we can see the YouTube, we can see the Zoom, because I know that Zoom is being utilized on the UDP port 8080.01. So pretty much everything is working as expected. So I think this is pretty much all what I wanted to share with you guys today. So we can now jump back to the presentation. So basically a short recap. So today we went through the SD-WAN in general. We talked about why the modern companies need SD-WAN, what are the benefits of SD-WAN. We talked about what are the benefits of Exinda SD-WAN and also the feature set of Exinda SD-WAN. And finally, we covered how the Exinda SD-WAN can cooperate with Exinda Network Orchestrator, and we saw that also live in the demo. So now, if you have any questions, I will be very happy to answer them, and please feel free to ask whatever you are interested in. So I see first question from Galina. Hello, Galina. So the question is if Exinda SD-WAN will be separate from Exinda Network Orchestrator. Well, at this first stage, we are offering 3 different boxes. As I mentioned before, I can quickly jump into that slide. So at the first stage, we are offering 3 boxes. So yes, the Exinda SD-WAN will be currently sitting on a different device or different box as is Exinda Network Orchestrator. But there might be plans for near future, and I can ask our product manager, VP of product, to have a better answer for you, and I will try to answer separately out from this webinar. Any other questions, guys?
Hi, Joseph. I do have another question that we need to answer. Do I still need a firewall if I install Exinda?
Well, this is a good question, but you know that firewall is in the network's use from the security perspective. That means that in many cases, when we are talking about the firewall, we are also talking about the UTM. So the antivirus and intrusion prevention and detection system and all these other features which are making our networks safe. So Exinda SD-WAN does have a firewall rules features. Yes, that's correct. But I would say we still need to have a UTM firewall in place to secure our network from attacks. And Exinda SD-WAN doesn't have a UTM functionality. So it doesn't have the intrusion prevention and detection system. It doesn't have an antivirus. It doesn't have a content filtering and these other features for which you are purchasing and renewing firewall and next generation firewalls and UTMs and all these security devices. So I would say, yes, you still need to have it. So there is a question from Greg. Hello, Greg. So does the Exinda orchestrator adjust the policies automatically if the SD-WAN loses one of the links? Well, the Exinda network orchestrator doesn't really have the information that the Exinda SD-WAN loses one of the links, because that's the benefit, right? So the benefit is that the users are not going to experience any downtime when one of the ISPs will fail. As you can see, the Exinda SD-WAN has 4 different ISPs. but the LAN port is only single, and this single LAN port is going to be connected to the Exinda network orchestrator. So the answer is no. The Exinda network orchestrator will not see any issue with the connectivity. The only thing what naturally will happen is that there will be a lose in the speed, because we are going to lose one of the ISPs. Any other question, guys?
Another question, does Exinda work with any telecom link such as ADSL, 3G or 4G?
I didn't heard the beginning of it, but I heard 4G. So yeah, I mean, you can also connect broadband, or you can connect basically, I would say, any ISP into the Exinda SD-WAN. Any other questions? We still have a few minutes. So another question from Greg. Could you use this on moving objects such as ships, etc., to pick up the links? Well, yeah, you can definitely have the Exinda SD-WAN on the ship. That's not a problem. You can, I don't know, have well, on many ships you have 4G, you have Setlink, so you have multiple connections already. So I would say the Exinda SD-WAN will be perfect device to sit on the board of a ship. Because what the ships are currently doing is that they are using multiple links, but there is no let's say automatic load balancing or no aggregation. But they are using one if the other one is out of reach or if the other one is failing. So they are currently doing it already, but they are not doing it as smart as it could be possible with an SD-WAN solution. Another question from Robert. So how would incoming connections be handled, port forwarding? So you can configure the port forwarding within the firewall capability of the Exinda SD-WAN. Another question is, how is working the solution with the clustering of boxes? Well, to be really honest, I do not really know right now, but I will search for the answer and we'll come back to you later.
Another question, how many links I can have with Exinda?
With the Exinda SD-WAN, as I mentioned in the beginning, you can go up to 12 internet connections. So the biggest box has 12 ports for internet connections. But from my experience, most of the companies have maximum 3 or 4 connections. So that was the reason why I chose to have 4 internet connections in my slide. But of course, there could be companies who have more. It really, I would say, it really depends on the nature of the business and how sure you want to be that you're not going to lose your internet connectivity. Okay, so I would say that we are all set for today. So if you will have any more questions in the future, feel free to send us a message. And also, if you are interested into demo or into having more sales-oriented information, then feel free to contact our sales director. Or you can, of course, contact your partners, resellers, distributors. They will be also very happy to help you and answer any questions you might have. So thank you very much, guys, and have a lovely afternoon.